Hello, everyone. So today I'm going to continue our conversation about the binomial distribution. We're not going to test the conditions. We're just going to do a few questions as a continuation of what we did last time. Remember, last time we only dealt with problems that says, what's the probability that x equals some number? P of x equals 2, P of x equals 20, P of x equals 5. And we use the binomial PDF, probability density function. Today, I'm going to expand on that. The presentation is short, but I'm going to expand on it to deal with at least, at most. So I'm going to work with the same problem. We had 20 light bulbs, and we have an 80% success rates, which means non-defective light bulbs. I think we had 16 good ones out of 20, which is 80%. And we had 20% defective light bulbs. So these are the numbers you're going to need. And we had checked the conditions already, so I'm not going to go over those. So the question now is, so here is one. What is the probability that at most 2 light bulbs are good? At most 2 are non-defective means find the probability that at least that x is less or equal to 2. At most 2 are good. It means either 0 are good, or 1 light bulb is good, or 2 light bulbs are good. Does that make sense? At most 2. Now, you don't know how to deal with this yet, but we can tell that if I say at most 2, it means I either have 0 or 1 or 2. Remember, P of A or B is P of A plus P of B minus P of the intersection. But you can't have an intersection here, right? At most 2 means either 0 or 1 or 2, which means you add the probabilities. There is no intersection. You don't have to subtract anything. Now, you know how to deal with each one of these from the previous session. So this one would mean 20 choose 0, which will give you one way to do it, 0.8 to the power of 0, and 0.2 to the power of the leftover, which is 20. 0, good, 20, bad. Okay? For this one, if you remember, we did 1 choose 20. You can go back to the previous session. This is just this, and this is just that, and this is just that. And I know it's a little long, but I'm going to show you a shortcut. So the probability that x equals 1, it means 20 choose 1, and 20 choose 1 will give you 20 ways if you do the math. And the probability of success to the power of 1, only 1 good. And the probability of failure to the power of 19 bad ones. And then you do the same thing here. So that's one way to do it, okay? Now, of course, you can just do binomial PDF on this one, binomial PDF of that one, binomial PDF of this one. But I'm going to show you a shortcut, okay, for less or equal directly. So let's push with another question, and then I'm going to come back to the graphing calculator. What about at most 18 are good? At most 18 means 0 good, or 1 good, or 2, or 3, all the way to or 18, right? Now, you don't want to do this approach again here, right? Because you would have to do this one, and this one, and the next one, and the next one, and the next one, all the way to the 18th one. Can you imagine adding 18 of those type of expressions? That's very long. So this is not the approach you want to take. I made a mistake here. I said at most 18. That means less or equal to 18. Right? At most 18. That means either 0 or 1 or 2 or 3 all the way, or 17 or 18. And by the way, how many expressions are here? It's not 18 of them, it's 19, because you start with 0, right? If you count from 0 to 18, there are 19 expressions, and each expression is a nightmare. So you don't want to break it this way. What we're going to do is we're going to take advantage of the complements. So I drew a little picture here. So here are my light bulbs, so to speak, or 20 options. In fact, there is a 0 option as well, right? You could have 0, good. Let me add 0 here. Right? So, if you think of this one, it means I'm asking you to add the probability that x equals 1 plus the probability that x equals, the probability that x equals 0 plus the probability that x equals 1 all the way to 18. Right? And that's why I said there are 19 of them. If you count from 0 to 18, there are 19 of them. Why compute all these blue dots when you can do 100% minus these two? I put them in red. So the probability that x is less or equal to 18, which is these blue dots, is just 100% or 1 minus the probability that x is more than 18. You can also say 1 minus the probability that x is greater or equal to 19. This is the same thing. More than 18, strictly more than 18, is greater or equal to 19, which means basically these two dots. So it's easy to compute these two than to compute 19 of them. So it's 1 minus 100% minus this or this. So what's this? It's either 19 or 20. And you know how to deal with 19 from the previous session. There is an equal sign. 20 choose 19, which will give you 20 ways, by the way, because 20 choose 19 is the same thing as 20 choose 1. And 20 choose 1, there are 20 ways to choose 1 out of 20. You can also use the formula or use a calculator on this one. The probability of success to the power of 19, because there are 19 of them, and the probability of failure to the power of 1, right? So this is just this from the previous assignments, the previous presentation. And we know this is this. So you compute these two, you add them up, and when you finish, you subtract that from 1. So it's much better to do 2 than to do 19 of them. From 0 to 18, there are 19 of them. Okay, so you never want to do this, okay? Never want to do this. It's too long. I don't want to compute the blue, and that is the purpose. This is why I talked with you guys about the complements. P of A complement is 1 minus P of A. Conversely, P of A is 1 minus P of A complements. 1 means 100%. That's what it means, okay? So sometimes it's better to use the complements, okay? So let's say I have 20 students in class, okay? 20 of you, and 2 of you show up. 2 of you show up, that's it, just 2. Does it really make sense to figure out to take attendance and start calling people by name, knowing there are only 2 sitting next to me? I would just count those 2 that are next to me and subtract that from the total, from the 100%. Does that make sense? But if 19 are present out of 20, I may want to take a roll and then figure out who's absent. But if I only have 1 or 2 present, it makes no sense to sit there and start calling people by their name when most of them are not even there. So the idea of the complements is really useful. I would rather compute these 2 than to compute this 19 blue. 19 blue means this, and 2 red means this. And whether you say x strictly more than 18 or say x greater or equal to 18, there is nothing in between. These are discrete values. There is only 18, 19. There is no such thing as 18.1, okay? So if you are more than 18, you have to be either 19 or 20, right? So this is exactly this, okay? In any case, however you look at it, you're going to end up with 19 and the 20. And add them up, subtract that from 1, and you should get the answer. Now, there is another method, of course. Remember what we did last time. on the TI, the probability that x equals, let's say 3, let's say green 3, let's say this is 3. What we did was the binomial PDF probability density function, and we wrote n, which is 20, p, which is 0.8, and x is whatever the heck I'm trying to find out. In my case, it's 3, right? If I have 1, I put 1. If I have 14, I put 14. Very simple. That only dealt with equal sign. True or false? Binomial PDF only deals with equal sign. Well, I don't have equal sign. I have this one. This is the question. Isn't that the question? Less or equal. When you have less or equal, you can use what we call binomial CDF. Not PDF, but CDF. Binomial Cumulative Density Function. This is binomial probability density function when you have equal. When you have less or equal, like here, like 18 here, you do binomial CDF and PX. So, and you can get all of this or all of this in one shot. You go to second vars, which is distribution. In the past, we went down to A. Now we're going to go to B. There's you scroll down until B, and you're going to see binomial CDF. And you enter your 3 numbers. Your N, number of trials, is 20. P is 0.8. And X, in our case, is 18. And you will get this for free. You will get all of this for free. Okay? There is only one problem. Binomial PDF works with equal sign. I think we're clear on it. Binomial CDF, on the other hand, only works with less or equal. So if you don't have less or equal, and you want to use the calculator, you got to trick it, make it less or equal. What do I mean by that? I'll explain. So in here, I was lucky. I have less or equal. So I just did binomial CDF. 20, 0.8, 18, boom, done. So here's what I just said. If you have less or equal, you just do binomial CDF, 20, 0.8, 18, done. What if I say, I want to find the probability that X is strictly less than 18? Okay? Now on the calculator, by hand, less or equal to 18, strictly less than 18. So basically cover 18, cover 19, cover 20. Basically means starting from here all the way to 17. True or false? Well, I don't want to count all of these, so I'm going to do 1 minus that probability plus that probability plus that probability. That's what I did here. It's 1 minus the leftover. Strictly less than 18 means going from 0 all the way to 17. Going from 0 all the way to 17. That's what I'm trying to find. 0 and 1 and 2 all the way to 17. But I don't want to compute 18 of them. There are 18 here. I don't want to compute them. I'm going to do 1 minus the probability of 18, 18, and 19, and 20. That is exactly what I did here. Read this carefully. Go back here and see if it makes sense to do 1 minus that plus that plus that. So you could do that. You know how to do this by hand. Subtract that from 1, or go back to the TI. My favorite, right? My favorites. The only problem with the TI right now is what? I don't have less or equal, do I? In here it was easy, but in here I don't. But I can make it less or equal. How? If it's strictly less than 18, it's the same thing. I'll put it in green. It is the same thing as less or equal to 17. True or false? That is the same thing as strictly less than 18. Now I have ensured less or equal. I can use my TI. How? Binom CDF N P X. Even though it says 18, you need to write 17 because you have to ensure less or equal. You cannot have strictly less and write 18 here because that's going to give you this one. Are you with me? So just to remind you how to get here, second vars, which is distribution, scroll down to B. A gave me the binomial PDF, the binom PDF. You want B, which is binom CDF, and enter the values. Number of trials is 20. Probability of success is 0.8. And X is 17, not 18. Even though you see 18 here, because I don't have equal sign, I don't have less or equal, I convert this into this. Okay? That is the tricky part. You've got to have less or equal in order to use the calculator. All right. So I'm going to give you a short assignment. I put one in words first because usually they ask you questions in words, and then I gave up. Keep it simple for you. Find the probability that at least 19 light bulbs are non-defective. And that's the question basically. All of this means this. So try to figure that out. Try to do it, honestly, you should try to do it by hand and on the graphing calculator. So by hand, what does that mean? Greater or equal to 19. That means this. You just have to do 19 plus 20, that's all. Right? I'm only asking for 19 and 20. So you could do them by hand. You can also use the calculator. But the calculator is tricky. Why? Because I don't have less or equal. So how do I make it less or equal? So let me draw a picture for you. So I have 0, 1. Actually, let me just go to the picture here. Okay, I said at least 19. Okay? At least 19, which means either 19 or 20, which I just did by hand. But how do I use the calculator? You can do 1 minus the probability that X is less or equal to 18. Isn't that true? Because if I want at least 19, which means either this or that, which means these two, I can do the complement and say 1 minus the probability that X is less or equal to 18. See how I converted? See how I converted this into this? And why would I choose to do this? This is in case I want to use the graphing calculator. So it's 1 minus binom CDF N P X. I just did the problem for you in 2 ways, okay? So you've got to be able to convert anything here into less or equal. Just by looking at those dots, you'll know what to do. Okay? So you do this problem. Try to do it in 2 ways if you can. And then I would like you to do this one. Say thank you. I already gave you less or equal. You could do it by hand. You could do it on the calculator directly. Then I said X strictly less than 1. So I want you to think about that. Either you do it by hand, and if you want to use the graphing calculator, you got to turn this into less or equal. And then strictly more than 18, okay? So 4 questions. Please show your work, okay? Show me how you got. Don't just say, okay, I know, I got it. 0.003% or something. I have no idea how you got this. I need to see how you got there. Just like I showed you. If you are in doubts, look at how much I show the work. Look, I wrote this like this, I wrote that, and I didn't even do the math here, right? But you've got to show your work, okay? So I'm going to conclude with a solution to the brain teaser that I gave you last time. I said, how can you multiply 81 by 9 and get 801? And one of you got it, by the way. You basically turn the page upside down. So if I turn the page upside down, I get 18 times 6 is 108, and that is true, right? So literally turn the page upside down, like 180 degrees, and 81 becomes 18, and 9 becomes 6, and 801 becomes actually 108. And if you multiply 6 by 18, you will get 108. Of course, 9 times 81 is 729, which is not true. So I said, how can you make this true? Just turn the paper upside down. All right. Short and sweet. Have a wonderful day, and I'll see you tomorrow, Friday. Bye-bye.